Wow. I mean, what else is there to say but wow? I feel like, Carl, we should have started with you. That's really, this is why we're here. This is why we're here. So, we have more pop-ups. This will be your last round of pop-ups. Again, hopefully they're short and sweet. Lisa has her whistle. Timer's back there. Although we do have someone standing in the way of the timer. Might you move? Thank you. Oh, wait, but you'll need to restart it. All right, so if I can call up our, let's see, we are on the final technology pop-ups. Come on down. And again, you'll present in the order you are on the slides.
Well, good afternoon. My name is Dan Simon, and I am the CEO of Basswood Incorporated, and we are driving a more sustainable future by developing better tools for water and wastewater treatment. Before I get into the details, I want to thank, I guess I should maybe speak it through this. I want to thank the Global Climate Action Summit organizers as well as the Water Pavilion team. We're not going to drive this planet to a more sustainable future with just a couple large changes or technologies. I've spent 25 years as an entrepreneur looking for that. And I think the reality is it requires the multiplying effect of millions of changes, not just the addition of a couple large ones. It all starts with communication, and this summit, as well as things like this, help get that communication started. For the energy and water industries, it will take a commitment from millions of people and billions of dollars of investment and hundreds and maybe thousands types of new technologies and new changes. We recognize managing waste isn't the most attractive of industries, but to drive humanity into a more sustainable future, we need to manage all aspects of economic evolution. This audience knows all this. What I can tell you is what drives me and what got me involved with Basswood are these three numbers: 1.1 billion people lacking access to safe water, 2.4 billion people lacking access to improved sanitation, and 3.4 million people dying each year, according to the World Health Organization, of water-related diseases. As you know, this makes it the leading cause of death on the planet. Human development is more closely linked to access to water and sanitation than any other sector, including health, energy, and education. Indeed, it's the most basic of all needs. If nothing is done, this problem's only going to get worse, because right now about 50% of the world's population lives in cities, and by 2050, 70% will. This is where Basswood comes in. We provide innovative wastewater and biosolids management solutions. We have patented technologies that effectively treat industrial and municipal wastewater streams. We currently have installations in the United States, Asia, and Latin America. We were founded in 2004 by a gentleman by the name of Paul Baskus and a few impact investors. Paul is a scientist and an inventor with a soil physics and a microbiology background. He grew up in a rural community watching rivers and how they digest waste streams. And it happens naturally and slowly, and he started to figure out as he was getting his degrees that these rocks were growing mats of bacteria, polycultures of bacteria, and they were basically digesting the waste slowly. And he thought maybe we could do this in a concentrated form. And over a number of years of research, he figured out how to do it in a can using a media. And that became what's called now the BioViper technology platform. We built our first facility at Dr. Pepper's full-scale facility at Dr. Pepper's plant in Houston, Texas. Since then, we've treated over 650 million gallons of high-strength wastewater. We've been able to digest over 20 million pounds of carbon wastes. This is all done with 60% less energy than conventional systems and with 40% better digestion of solids. Our robust treatment systems deliver high-quality water that can be reused as well. So, gray water systems that can be treated for landscaping, fleet washing, boiler and cooling tower makeup water. In preparation for making a commitment, and we came prepared to make a commitment. I'm not sure it fits for all companies, but in preparation for this week's summit, we've confirmed Basswood systems have saved over 11 million kilowatt hours of electricity which is the equivalent of 8,400 metric tons of CO2, and is the same greenhouse gas emissions as 20 million miles of cars being driven, or the equivalent of 10,000 acres of U.S. forest, the amount of carbon that 10,000 acres can sequester. With this quick intro, Basswood is thrilled to offer the following commitment for the next 5 years. Between 2019 and 2024, Basswood will save 10 times the amount of water and energy it saved in the last 5 years. This is 6.5 billion gallons of reusable water, 200 million pounds of BOD of organic waste processed, thus saving over 110 million kilowatt hours of electricity, 84,000 metric tons of CO2, or the equivalent of 100,000 acres of forests sequestering carbon. I recognize this sounds like a lot to me, but we are just one tiny little tool in what needs to be done, as you guys are all well aware. But we do appreciate the opportunity to present what we do, and I wish you all a wonderful end to this conference. Thank you.
Hi, everyone. It's a pleasure to be here today. I should do the same, make sure I'm talking in. I'm Gia Schneider. I'm co-founder and CEO of Natel Energy. We're a Bay Area-based company over in Alameda, and we are working on a solution at the nexus of water and energy that we call Restoration Hydro. So what is Restoration Hydro? Restoration Hydro is an approach to transform the way we develop hydropower by taking lessons learned, proven civil and environmental engineering techniques that have been used in watershed restoration over the last decade and a half or so, and combine that with a new technology and a new approach for distributed, compact, modular, fish-friendly hydropower. And that by doing so, we can then create a solution in watersheds, a watershed solution that pays for itself with energy. And so why Restoration Hydro? I know this is the Water Pavilion, and we're coming at this with a bit of an energy solution. It's part of why we were drawn to hydro in the first place was because we're very motivated, obviously, by climate change. And climate change, if we think about how what faces us ahead as we work to address climate change, is really about thinking about both mitigation, so how do we reduce emissions, but also adaptation, and in particular, adaptation through building resilience, through building climate resilience. And as we all know, water is really where we're going to see some of the biting effects, already are seeing some of the biting effects of climate change first and foremost. And so hydropower really appealed to us as we started to think about how we can make a difference on climate change as this solution where if we're able to deliver solutions that help pay for themselves with energy, but deliver watershed uplift, deliver watershed function, that was a really interesting way for us to help make a difference and contribute. And so how? A lot has been talked about over the last couple of days about nature-based solutions, about looking to nature in terms of how we might go forward from today. And that's also where we started. So we looked, if you were to rewind back 200, 250 years ago here in the West was full of beaver. And the West was full of water in certain places. The West has always been arid. But in our rivers were full of beaver. And between then and now, Western watersheds in particular, just as an example, have undergone two huge changes. One was mass removal of beaver, and the other was building a huge infrastructure of water infrastructure, dams, et cetera, to move and deliver water. And so with that in mind, we said, okay, there's a distributed approach here that we can learn from. And beaver are called nature's engineers for good reason. And as we dug more into that, we started to understand how you might take civil engineering approaches that are able to help drive groundwater recharge, help enable, still account for fish passage, help create habitat, wetland habitat uplift as well. And then we paired that by looking forward, by using some really interesting techniques around advanced manufacturing and advanced materials. In particular, carbon fiber for us is really important in the design of a new turbine technology that is compact, modular, fish-friendly, and scalable, and able to be deployed in a distributed manner. And we combine that by also looking forward and taking advantage of some really transformational tech in the sense of cloud computing, big data, machine learning, to enable us to analyze solutions and design solutions at the watershed scale, right? Because if you're talking about distributed hydro, you're talking about doing a lot of things across a watershed. You need to be able to not just design, build, but you also want to be able to monitor what's happening at the watershed scale. And through that, we were able to build this really cool platform called Upstream to make that possible. So our goal frankly, is so today we are commercially deploying initially in the built water infrastructure space in irrigation and some small non-power dams. That's kind of our initial couple projects in the ground going to market. But our big audacious goal and why we're really in this is we want to drive 300 gigawatts of new distributed restoration hydro globally to deliver an offset or to drive out a gigaton annually of CO2 emissions while we are restoring watersheds, while we are returning climate resilience and health into our watersheds around the world. And today what we have to offer specifically, or actually it might be a little bit more of an ask, is that we just launched one program called the Upstream Impact Accelerator, and in that we really want to work with NGOs, water agencies on if you have a project where you're looking at where you think planning, machine learning driven automated tools to help drive planning and monitoring of watershed restoration projects would be useful. We would love to talk with you and work with you. And the second is we are launching an effort to build up a portfolio of restoration hydro projects here in the US to start. And again, if you are working in a watershed that you think this could be a useful tool, that restoration hydro could be a useful tool, we'd also love to talk with you. Thank you very much.
Good afternoon, everyone. Thank you so much for this opportunity. My name is Fatima Shirazi. I'm CEO, founder of Macrovi Biotech. We are based in Bay Area, and we focus on cross-section of material science and microbiology to bring new technologies for generally waste-free technologies for water, wastewater, and renewable energy. I would like you to take a moment and imagine what would be the most difficult pollutant in drinking water. What comes to your mind? Perhaps you think about arsenic, chromium, lead, perhaps. You have heard about Flint, Michigan, and you have seen movies about all kinds of water pollutions. But there is one contaminant that is extremely dangerous, affects more than 1 billion people around the globe, and yet fewer people know about that. Any guess? No? Nitrate is the world's #1 drinking water contaminants. Nitrate comes to our groundwater, enters into our groundwater through fertilizer, which means that as we strive to keep feeding our growing population, there is more and more nitrate that we have to deal with. A major challenge. We basically don't lack any technologies for nitrate treatment. But what is so important is that removing nitrate cannot be done by filtering it out. And the technologies that are available, such as ion exchange or reverse osmosis, they're all generating what we call it a secondary waste stream, which is obviously bad for the environment. So across agriculture regions such as US, Europe, India, China, and Africa, trillions of gallons of fresh water are locked away due to the high concentration of nitrate. And it is shocking to know, this is really important, this is the reason we are all here. Nearly 1 billion people currently are drinking nitrate-contaminated water. And out of that 1 billion people, there are 200 million people that are drinking nitrate-contaminated water 10 times more than World Organization suggestion, which is 50 milligrams per liter. And this is at the time that 5 milligrams per liter has been linked to various cancers, as well as many chronic diseases. So I founded Macrovi with a vision of finding real solutions for major challenges we have in water, energy, and environment. I knew that incremental changes to waste-generating inefficient and costly technologies would not be the answer. So my journey, this is the interesting part, my journey actually took me deep into the nature where microorganisms are living and evolving over billions of years. What's their secret? How can their fascinating mechanisms or capabilities help us to treat our water and have sustainable solution? The outcome of journey was a technology called macro-niche engineering, and this is unlocking the power of biology and nature through material science. Our company is uniquely positioned to deliver on that promise. We have installation in Australia, in California, proving that our technology works. And what is so important is that we treat hundreds of millions of gallons of water without producing a gram of solid, no impact on the environment. So today our commitment is to reclaim 1.5 trillion, with the T, gallons of nitrate contaminated water by 2023. That means that would reduce about 76,500 metric tons of CO2 equivalents. Most importantly, we will improve the lives of hundreds of millions of people who are relying on contaminated water. We hope that this commitment, combined with the pledge of our fellow participants, will be one piece for achieving greater water sustainability for the sake of our planet, our lives, and our future.